All right, we're continuing on with section 12.3, and on this first example we're going to look at a couple of different situations where one person is depositing, Mandy is depositing $40 a month for 34 years and Sam deposits $80 a month for 17 years. Both accounts are going to earn the same amount of interest, 3.8% compounded monthly. So before we go into the TVM keys, we're going to check and see how much each of them deposit. And if you are thinking, hey, I think it's going to be the same, then you are right, because Mandy is depositing $40 12 times per year for 34 years, and that's a total of $16,320. And then Sam is depositing $80 per month for 12 months per year, and that's 17 years, so he deposits exactly the same amount as Mandy. That's a weird looking little comma there. Okay, and so we're going to actually find both of the future values for these two. So let's fill out the chart. And okay, so on the first one we have 34 years times 12 equals, we'll put in 3.8% on both of these, so you can actually not clear everything on this particular question. When we put an arrow like this, it means that we're leaving that the same. This one's going to be 0 present value because we're making payments, right? We don't have a present value. We're depositing $40 per month and $80 per month. I guess I should have gone back and filled out this part. Now, of course, we can only put one of these at a time on the calculator, right? Okay, I guess I should make these two the official way. We are computing. How about CPT? We're going to compute future value for both Mandy and Sam. And so when you're going to put this all in your calculator for one of them, and then on the second one you just have to change your number of periods, and you have to change your payment amount to calculate or compute, I guess I should say, your future value. So the future value for the first one, the Mandy example, is going to be $33,254.35. And you might think to yourself, I wonder which one is going to deposit the most money. All right, so there's one of my answers. And then when you compute for Sam, you will get a different answer. And so for Sam, the total is $22,887.10. And so you see that it is a different amount even though they deposited the same. So Mandy's ends up being more, and you might just want to think about that. Why? Why did that happen? What do you think? And based on how much they each deposited in their accounts, find the amount of interest Mandy earned and the amount of interest Sam earned. Okay, well, for this we are just going to do some subtraction. Okay, so for Mandy earned $33,254.35, and we subtract the $16,320, the amount she deposited, for a total of $16,934.35. And then Sam was 22,000, the commas in here, 887.10. We're subtracting $16,320. So Sam earned $6,567.10. Now we're going to find the difference between these two by subtracting, and we find that Mandy earned $10,367.25 more than Sam. So are they the same? No. Mandy earned $10,367.25 more interest than Sam. Now, the reason for that has to do with time, because as she deposited her money, it would compound each month, and so it would pay on more interest. And so the $40 went in every month, but it went on for 34 years, and that's honestly what made the difference, right? As she was depositing her money, what was it, $40 a month for 34 years, she was able to earn more interest just because it was more often and for longer. Well, it wasn't for more often, but it was for longer, right? Twice the number of years, and that's what made the difference. Okay. So now these are some practice questions. Some of them are similar to ones that we did on previous questions, so let's take a look at them. So Mickey D spends $200 a month eating at McDonald's for lunch every day and is considering packing a sandwich for lunch instead. Alright, so $200 a month. Mickey just turned 23. If he deposits the $200 each month into a savings plan earning 4.3125% compounded monthly, what will the balance be when he turns 40? Now, we do have to do a subtraction on this one. So for 17 years, this is what we're going to be using for our number of periods. Okay, so 17 years. Let's see, this one was compounded monthly, so 17 times 12. Push your equals key before you enter that. For the I, we're going to put in 4.3125 and divide that by 12 equals, remember you have to put the equal sign to get the number on your screen, and then you push I. The present value is 0 because he's making payments and only payments. So payments of $200 per month, and then that means we will compute the future value. And the future value for this particular question then is what goes here. Alright, so let's see what the future value was. And it is $60,039.88. All right. And so that's a pretty good amount of money for just depositing what you would have been spending on eating something at McDonald's. Okay, next question. At your local bank, you decide to open a money market savings account paying 7% interest compounded quarterly. When you open the account, you deposit $600. Then at the end of each quarter, you deposit $100. So every time it compounds, you're depositing $100. What will the account balance be at the end of 2 years after your 8th deposit? Now, this one is not really anything tricky. There's just an extra part here that we maybe haven't looked at before. So for 2 years, compounded quarterly, so 8 times. It just even said that in the question. Our interest rate is 7%. We're going to divide that by 4 because it's compounded quarterly and put our equal sign before we enter that on our calculator. The present value is negative and it's $600. The payment is negative, and that's $100. And then we will compute the future value for this question. All right, so that's where we're going to circle. Try to get that more even there. Okay, so for this question, the future value is $1,540.08. 8 cents. Okay, well, we're up to about 10 minutes on this video, so we will stop now, and then I will record another video for the rest of the practice problems on this section.